Why we use radians really comes apparent in this section. Because really, if what happens if we want to solve something like this, graph graph sine of x and 1 minus 2x at the same time, or cos of x and log of x. If we're dealing with degrees, we won't be able to do this because we can't express that as degrees on the x-axis and just numbers on the y-axis. We could do it with sine x, but not with 1 minus 2x, and not with log of x. So what we do is, like, we these ones, as we say, like, we can't use a normal operations to solve these ones. The best thing we can do is draw a graph, and because they transcend the normal processes. So if we have to draw something like this, sine of x and x minus 1, really all we can do is show graphically the equation here. What we can do it, get an approximation, but we have to use some things like Newton's method, which is an extension 1 technique. So we're not expected to find necessarily a really good approximation of it, of the intersection of the curves. But what we should do, we could find a rough approximation, or just really how many solutions there are in a set interval. So here's the two curves. There's sine of x. And that's why we're in radians, because we can match up the radians. That's about 3.1. That's 3.14. So a little bit over 3. There's 3 there. So if we want x minus 1, you can see it's still got a gradient of 1, and it goes through minus 1. So it goes through there. That'll be at 2 there. Because 1 there. Was 1 minus 1 is 0. So that's 0, 1, which is one's a little bit less than pi on 3. So you can see there, if you're going to try and match up where it intersects, so if we have a look, it's close to about 2, which is a little bit less than 2 pi on 3. An approximation would be 2, because that's where it looks like it's intersecting. Again, it's not going to be a great approximation, because we're not getting a really good look at it. But we can see in this interval, it's only going to cut once. It's never going to cut again, because that keeps oscillating that way. And this one's a straight line there. So it's only going to get one solution in that situation. So if we have a look at this one, drawing the 2 on this, 4 cos x, similar to the cos curve, except it's been increased fourfold because it's got an amplitude of 4. And then you've got 2 minus x, so it goes through 2. It's going through 2 there, that's 2 there. So, and it's got a negative gradient, and it would intersect 3 times there, and we can pick out how many intersections we're going to get because we can draw it up. So really, we're not looking too closely, because it's still going to be really pretty difficult to get an approximation. We get a very, very rough approximation, but we can see how many solutions we're going to get with our graphs.